Assalamualaikum warahmatullahi wabarakatuh, students, and welcome to another physics video lesson. For this week, we're going to look at topic number 4.2, and in this topic, we're going to talk about gravitational fields and also something that's called inertia. These are the learning objectives for this topic. So at the end of this topic, what you need to know is you need to state what is a gravitational field. You need to be able to describe what is inertia, and you need to be able to remember the value of G on Earth, which is 10 newtons per kilogram. Okay, let's start. We're going to talk about gravitational field first and something that we call gravitational field strength. A gravitational field is a region where a mass experiences gravitational attraction. So what is a gravitational field? A gravitational field is basically an area or region around a specific object where if you were to go into that area or you go into that region, you will feel gravity acting on you, especially when you have mass. So if there is a mass that goes into the area, the mass will feel a gravitational effect on itself. So there is a gravitational attraction. We are in the gravitational field of Earth, so Earth has gravity and therefore Earth has a gravitational field around it. This is why Earth's gravity is pulling us down towards the Earth. And this is what the gravitational field of the Earth looks like. So it looks like arrows, and it's a radial field, it's a circular field, and there are arrows pointing towards the Earth because the gravity is pulling us towards the Earth. If we are on the ground, so on the ground, the gravitational field will look like this. So let me just draw it for you. Okay, so if you look at the Earth from its entirety, so from space, which is from this view here, the gravitational field is actually spherical in shape. It's radial in shape. But on the ground, because the ground is much more flatter, when you zoom in into the Earth, the gravitational field looks like this. It's pointing vertically downwards to the ground, like this one. Okay. Gravitational field strength, it has the symbol G, is defined as the gravitational force per unit mass. So gravitational field strength tells you how strong the gravity is. That's why the name is gravitational field strength. And it has the unit of newtons per kilogram. A stronger gravitational field strength means that the mass in that field experiences a stronger gravitational force. So an example of this is the moon has a weaker gravitational field strength than Earth. So if I remember correctly, the moon has a gravitational field strength of about 1.6 newtons per kilogram, whereas on the Earth, it has a gravitational field strength of 10 newtons per kilogram. So as you can see, the Earth has a bigger gravitational field strength, so that means the gravity on Earth is stronger than the moon. And this is why we can jump very high on the moon, because the gravity is weaker there and we feel much more lighter. Like I said, the gravitational field strength near the surface of the Earth is 10 newtons per kilogram. So that is a very important value that you have to remember for your exam. So by now you probably have noticed, you have seen this symbol before, this symbol G and this value of 10. Where was it? You saw this symbol and this value in the previous topic. And this is the same value and the same symbol for the acceleration due to gravity on the Earth, which is also 10 meters per second square, which is also 10, but except that the unit is different, and it has the same symbol of G. In fact, the gravitational field strength must always be the same as acceleration due to gravity. So these two things, in terms of values, they are always the same. Right, so for this slide, I'm just going to show it to you for you to copy in your notes, okay? So I will explain something different than this slide here, which is coming up next. Okay, so pause this video and then copy this to your notes, and then we'll move on to the explanation of what this slide is talking about. All right, so the slide is talking about where you got or where we get this formula W is equal to M times G. So where does this formula come from? This formula actually comes from the force, the formula for force. So the formula for force is this one, Newton's second law. F is equal to mass times acceleration, right? And we know what is the force for this case. The force is the weight. So weight is the gravitational force acting on the object. The mass is the same. The mass is mass. And then for what is the acceleration in this? What is the acceleration in this case? The acceleration is the acceleration the object is having when it is falling down towards the earth. And in this case, the acceleration due to gravity, which is what we call g. And this is where the formula comes from. Now, where do we get the unit for g? It's g meaning the gravitational field strength. Again, we can use this formula here. And we rearrange the formula to make g the subject of the formula. So g is equal to W over m. We know the unit for W is newtons because it's a force. And the unit for mass is kilograms. And you can see from this, Newton is over kilo, weight is over mass. So Newton, in other words, when it comes to the formula also follow the same type of relationship. So the Newton, the unit for weight, is over the unit of kilogram. So at the end, the unit for G is therefore Newton over kilogram, or what we call Newton per kilogram. Okay, let's do an example. Example number 2. A man called Darren has a mass of 5.8 kilograms on Earth. One day he decided to go to Mars to live there. The gravitational field strength of Mars is 8 newtons per kilogram. What is Darren's mass on Mars and why? So to answer this, on Earth, Darren's mass is 58 kilograms. And on Mars, what is the mass of Darren? It is the same mass, which is 56 kilograms. So the mass doesn't change. What is Darren's weight on Mars? So this one, the weight does change because on Mars, the weight is dependent on the gravitational field strength or the gravity of the planet. So we have to use this formula, W is equal to mass times gravitational field strength. And what we basically have to do is we put down the values there. So the mass is 556 kilograms. And the gravitational field strength is 8 newtons per kilogram. So 56 times 8. Grab your calculator and calculate it from there. Is 448 newtons. So that's the answer for B. C. What is the acceleration due to gravity on Mars? Now the question is asking the value for acceleration due to gravity on Mars. We know the gravitational field strength is basically has the same value as acceleration due to gravity. So basically this answer is very simple. It is also 8. The value is also the same, 8, but except that the unit is different, meters per second squared. There you go. Now let's talk about inertia and also mass. So inertia is something that is related to mass. So let's look at what it is. Inertia is the resistance to change in its state of rest or motion. So in other words, if an object is stationary, it shows a reluctance to move. If it is moving, it shows a reluctance to stop. So inertia is all about how hard it is to change the motion of an object. Try to imagine pushing something, okay? When if you want to make it move, you have to give it a little bit more force when compared to when it's already moving. When it's already moving, you only need to do a bit of force to keep it moving. And also, you need a bit more force in order to stop an object from moving. So if an object is already moving, if you want to stop it, you have to give it a bit more force in the opposite direction to stop it. And this is what inertia is. Inertia is basically how hard it is to make an object to move or stop an object from moving or changing the direction of an object. If an object has big inertia, then it's harder to move or harder to stop. If an object has small inertia, then it's easier to move or easier to stop. Okay. The word reluctance means unwillingness to do something, and resistance means the refusal to accept or comply with something. So how hard it is to inertia is the resistance or the reluctance of an object to change its motion. So how hard it is to move an object or stop an object. So examples of this, it is harder to move a 1,000 kilogram boulder than it is to move a marble. So a boulder has bigger inertia because if you want it to move, you have to push really hard. And if you want to stop it, you have to really push really hard. So it has big inertia. And for a marble, it has small inertia. So you just have to give it a small force and it will move, or you just use your finger to stop a marble. Or when you are riding a car and you aren't wearing a seat belt, when the car stops, you fly forward. So that is also an example of inertia working its effect. When you are in a car, you are already moving, and then when someone press the brake suddenly, if you are not wearing a seat belt, your body will want to continue moving in the direction that you are moving. So that's why your body will move forward because it takes a while. It takes a lot of force to make your body stop. And because you are not wearing a seat belt, there are no forces acting on your body to stop your motion. That's why you just move forward and probably hit the object in front of your seat. A bigger mass has a bigger inertia, so the heavier the object, the harder it is to move or stop or change directions. For example, a supertanker can be completely stopped after a distance of 10 kilometers, while a small boat or a canoe can be stopped in a few meters only. So an object with a bigger inertia takes a while to stop, while an object with a smaller inertia takes quite a short time to stop. Since inertia is dependent on mass only, it is unaffected by gravitational field strength. So no matter where you go, inertia will still have the same effects as it is on the Earth. So for example, a bus would still be harder to move than a tricycle even if both of them are on the moon. So on the moon, the bus is still heavier than a tricycle, so the bus is harder to move or harder to stop when compared to a small tricycle. And that is the end of this video lesson. So I hope everything is clear when I explain about gravitational field and when I explain about inertia. So just to summarize again, just to explain everything again to make sure to reinforce your understanding. What is a gravitational field? A gravitational field is basically a region or an area around a certain object. When you enter the field or enter the area, you will experience a gravitational force, or you will experience gravity pulling you down. So the Earth has a gravitational field. That's why we feel the Earth's gravity pulling us down towards the Earth. Then we looked at inertia. What is inertia? Inertia is basically the resistance or how hard it is to move an object from a resting position to a moving position, or the opposite from a moving position to a resting position, or when you are changing direction. If an object has a large inertia that's very hard to move or very hard to stop, if an object has a small inertia that is easy to move and easy to stop. And also finally, we talked about G on Earth, the gravitational field strength on Earth, and that is 10 newtons per kilogram. So I will stop the video lesson now. Thank you all for watching. Stay safe and I'll see you next week. Assalamualaikum warahmatullahi wabarakatuh.